Oops. All right. So now let's try and just make another model in OpenSCAD. This one I want to make a funnel. And just full disclaimer, I tested these before and I've got the script written out right next to me, so I'm not just pulling them right out. So there was some experimentation that I might forgo, just to put things in context. All right, so the user variables. So you think of like a funnel, you're gonna have, the big thing is the top. So I'm gonna call it the top radius. The bottom radius. The height of the funnel, right? That's another big one. The thickness of the plastic that the funnel is made out of. This could be variable, but usually I like to keep it constant. Constant throughout the entire model, that is. And then let's have a little brim at the top for structural rigidity. So let's brim width, and I'm going to call that just 10 millimeters. The height of the spout, let's call that guy 40. The handle width, I'm going to call that 30. And the handle length, length we'll call 70. Let's miss a semicolon there. All right, and then we'll say maybe some system variables. Say fn equals 50. I'm going to say my little extra variable. Throw that in there. Then we're going to have some calculated variables. So the calculated variables, I want to be able to find the volume of this guy. Because something that we're going to do is we're going to put in some logic that if the volume is above a certain amount, that we might want to add a handle or even two handles. That's what I'm going to do. So the volume of conic section, it's just something that I looked up, right? So that's going to be 1/3 times pi times the funnel height times the top radius squared plus the bottom radius times the top radius plus the bottom radius squared. So we've got that, but the thing is we need these units are in millimeters and we want liters. And so first I'm going to get to square or cubic meters. So I'm going to multiply this by 10 to the -9. Put them parentheses there. And then there's 1,000 liters in a cubic meter. So we're going to multiply that by 1,000. Just a smidge. There we go. So now I've got our volume here, and that's just going to be used for some logic. We're never even going to use this volume. All right. And something just for debug, I kind of want to know what this value is, comes out just to see kind of. So I'm going to echo. So this is going to spit out over this prompt here what the volume is. So right now we should be able to see what the volume is. And oops, forgot some semicolons. So I'm going to preview this guy again, and oh, that's strange. Yeah, so in the current version I have of OpenSCAD, on this computer, looks like the square isn't supported. So actually, what I'm going to do is just there. I should fix it. Oops. Oh crap. All right. So what can I do here? Well, I can go to the. We'll go to OpenSCAD cheat sheet, and I'm pretty sure I should be able to do. Let's take a quick look here. So it's probably going to be right here, power. So, yep, right here. That's what it's talking about. But I want to do power, and so it's the decimal and the exponent. So the base and the exponent. So you want to do power. Here's what you want to do. You want to do pow 10 negative 9. There we go. And so this is 1.84 liters is what this looks like it turns out to be. All right, very good. So first let's make the solid part of our object. So I'm going to make a union, and we're going to define all that. So first off, I want to make the main part of the funnel. So that's going to be a cylinder. Remember, we use cylinder to make our conic section. The height is obviously going to be funnel height, and R1 is going to be our bottom radius plus the plastic thickness, because we want to be able to add on. We want the internal radius to be what we specified, and then the external is going to be for the plastic. So, oops. And R2 is going to be the top radius plus plastic thickness. And let's just see what this looks like. I got a problem here. Plastic TK. Did I spell something wrong here? Oh, that's what I did wrong. Is that S missing there? Perfect. Okay. Boom. So there is one part. All right. Now, what we need to do is add in the spout. Right. So, first, what I'm going to do is I'm going to mute my computer because someone's trying to talk to me. Yeah, so first what I'm going to do is create the geometry for that cylinder, what that's going to look like for the spout. So that cylinder is going to be, well, its height is going to be the spout height, which is a variable that we brought in. The radius, it's going to be the same as this radius right here, which is just R2, or sorry, R1. And that should be it, actually. So obviously we preview this, and the cylinder exists inside of here. So the next thing we need to do is translate this downward if you actually want to be able to see it. And how far do we translate it? Well, that should be just in the z-axis, right? So nothing in the x, nothing in the y, and the z-axis, and it's going to be spout height. Now I made a mistake here, but let's say we did this and just previewed it. What happened here? Well, we went in the wrong direction, right? We needed to go negative, or in the negative z direction. So if we're negative, boop, there's our little spout. Cool. So we got that. And another solid thing we need to make is our little brim. We want to put like a little ring around here to add some rigidity. So to do that, well, here, let's comment things a little bit better here. We'll say create the spout. And now we want to create the brim. So let's see what that turns out to look like. It's going to be a cylinder, and the height of it is just going to be our plastic thickness, because we're going to use that variable whenever we can. And now the radius is going to be this top radius, but instead of plus plastic thickness, it's going to be our brim width. Bonk. Oops, I need to do this. Sorry, I need to say R equals. There we go. Bonk. And so now clearly you can see we've got to translate this guy up. So let's tab this in, make another translate, and it's going to be close to this guy right here. Not quite, but I'm going to copy this. So this should be translated up at least funnel height. Let's see what funnel height gets us. Bonk. Okay, so that got us to the top. So that's not quite where we want to be, though. Where we actually want to be is we want to be a little bit lower. And hold up, let me double check and make sure this is exactly right. Plastic thickness, top R. Yeah. So the only thing we need to do is this is just above the cone. We need to bring it down. So if we're going to bring it down, we need to just subtract the thickness of the plastic, or basically this width here. So there we go. So now we're right where I want to be. Now, finally, we want to make the handles, but we only want to do them conditionally. So we're going to say conditionally create one handle. So we're going to say if the volume is greater than 1 liter, we're going to make one handle. So if volume is greater than, we'll say equal to 1. And so if that's true, then we are going to make the handle. So what's the handle going to look like? Well, it's going to be cube, and it's going to have the handle length and the x dimension, the handle width and the y dimension, and the plastic thickness and the z dimension. Okay, so right now our volume here is 1.84, so we should see this when we preview it. Oh, but that's not where we want it. So there's a couple things. We know that we want it to be at the top, and we also need to kind of center it out in the y-axis. We need to move it a little bit back in the y-axis. So let's do that. We're going to do some translating. And what are we going to do from there? Well, so our translation, we need to move it up. So we're going to move it along the x-axis this radius. So it's just on the edge there. So let's do that. That's going to be top R. And then we need to go back half this guy's width, half the handle's width in the y-axis. So that's going to be handle width divided by 2. And finally, we just need to go up funnel height minus plastic height, which is going to be the same thing as this brim here. So I'm just going to copy that. Now it's on the same plane as the brim. Oops, this needs to be negative. We went in the wrong direction. Ta-da! So now we got one handle. So theoretically, if we bring this down, bring the size smaller, so now the volume here is about 0.5 liters, and so the handle disappears. So that works. So there we go. Now, what we need to do is conditionally create a second handle if we are at 2 liters is what I want to do. So if we're greater than or equal to 2, and I'm just going to keep all this in here. And all I'm going to do, this is me being just a little lazy, is because I could hard put all these dimensions here, but instead what I'm going to do is rotate along the z-axis 180 degrees. So 0, 0, 180. So this is conditionally creating the second handle. Okay, so let's test that out. So we're at 1.8, so we don't have to go that much higher to get 2 liters. Let's go 50, 150. There we go. We got 2 handles on there now. Pretty cool. Let's go back to just 1. All right. So now this is our whole solid object, right? We've got our whole solid part here. Now we just need to kind of hollow out the spots we need to hollow out. So I'm going to tab this whole guy over. So I'm going to select it and just press tab. So we're going to have to do a difference. So this whole union is the solid part. So it's a good thing that we have this all union, because only the first part listed in difference can be positive. And now we need to cut out the interior part of the cone. So just here's what I'm going to do. It's going to be pretty similar to this cylinder that we started off with. So I'm going to start with that as my baseline, actually. Obviously, we don't want to just keep it at this, because if we kept it at this, what's it complaining about even? Oops, I'm missing a curly brace here for my end of my difference. There we go. Yeah, so actually, surprisingly, this isn't quite glitching out as much as I would have thought it would. But yeah, that's not quite what we want to do. One thing, we don't want our radiuses to include plastic thickness in there. So I'm gonna pull that out. Right, we're gonna pull plastic thickness out of here. And my other thing is I'm gonna add just a little bit onto this. Just a little bit of height so it pops off the top too. Boop. Right, so it looks like sometimes on my Linux system things are a little bit more cantankerous. I'm gonna add my extra just to be a little bit bigger. There we go. So you can see that sometimes when you're subtracting just on the edge of your mesh, you end up with this kind of ill-defined. Is it supposed to be subtracted? Is it not? And of course, if I render this, that problem won't come up at all. But obviously the preview is much quicker, and I do it quite frequently, and so that's usually just kind of this extra is just a trick that I kind of use to make it so I can preview things quickly. So I could conceivably set this to 0 before I render it, just to remove any of that extra kind of tolerance out. All right, so our last step is actually to cut out the interior of the spout. So once again, I'm actually just gonna start with this as my baseline. All right, oopsie daisies. Let's do this. There we go. All right. So we know we need to take this plastic thickness dimension off because it's just the interior, right? We're not including the radius of the added plastic. Don't forget our semicolon there. What's that leave us with? So check it out. We've got another one of those problems where we're just on the edge, and so that edge is kind of like ill-defined. So here's what I'm going to do. I'm going to add some extra to both ends. So I'm going to say extra times 2. And then I'm going to, so let's see what that does. That takes care of the top part, right? The top part of this hole is all good, but the bottom part is still a little messed up. So I'm going to shift it down in the z-axis with this translate statement, just by one little extra step. And there we go. So that's our complete funnel. Now we should be able to ring this out in all sorts of ways, and it should be fine. So if I want to say I want my we'll say funnel to be taller. Okay, so it's taller, cool. And look at that, that brought us up into the 2-handle area, because when we're at 200, oh, we were still on 100. Yeah, so that's all working pretty good. We'll put that back at 250. And maybe I want to make this even smaller. Maybe I want to make this just 10. Okay, so we're there. Plastic thickness, maybe I want to conserve that a little bit. I'm going to call this like 5 millimeters, because right, that's a centimeter thick plastic is what they had that at before. Yeah, so everything seems to be scaling the way I would expect, which makes me very happy. And so I think this is good to rock and roll. I should have saved it a long time ago, but I'm going to save it now. And so we'll just call this funnel.scad. Coolio.